Okay, we're going to look at number 16 in section 2.5. We're evaluating the limit, but we're going to do it in terms of the constants involved. So what do they mean by the constants? Well, you can see we're taking the limit as x, that's the variable, as x approaches what a. A is a constant. So a is some fixed real number. It's not a variable in that sense, right? What's changing is x in this problem, right? As x gets closer and closer to some fixed value of a, what's the value of this, what's this function approaching or getting closer to? So when I plug in x equal a, obviously up top I get square root of a minus square root of a, which is 0. And in the bottom, obviously I get 0 because I'll have a minus a. So we just replace x with a. So it's indeterminate form. So what are we going to do? Well, some of you might see up top and say, hey, we've got these radicals. Let's rationalize the numerator. And that's what I'm going to do first. And I'm going to do that by the conjugate. Do you remember what the conjugate is? The conjugate, what is the conjugate of the square root of x minus the square root of a? It is the square root, what, conjugate? Conjugate. I can't spell today. The conjugate is the square root of x plus the square root of a. That's what I'm going to multiply by, right? And why is that? Well, that will rationalize the numerator. Of course, I'm going to do that to the top. I have to also do that to the bottom so that the grand total that I'm multiplying by is equal to 1. So up top, what happens? The square root of x times square root of x is just x. The outer becomes the square root of x times the square root of a. The inner is negative square root of a times square root of x, negative square root of x times a, square root of a. And then the last is negative square root of a times positive square root of a, which is negative a. But notice what happens here, right? And you don't even have to write this out here because we know that's going to happen, right? So I'm just going to be left with x minus a. Now on the bottom, I do have to multiply these two things times this, so I'll make sure that that's in parentheses, right? The square root of x plus a. Top is just x minus a now, right? After that goes away. And so I can divide top and bottom by this common factor of x minus a. And what am I left with? Just 1 over 14 times the quantity square root of x plus square root of a. Notice I've kept my limit every time, and now I can plug in, let x be a, and I can evaluate this, right? Replace x with a. I get square root of a plus square root of a. That's 2 times the square root of a. 14 times 2, 28 square root of a. So I get 1 over 28 times the square root of a. There's the exact value of the limit in terms of that constant a. Now, I just want to uh, make note, when I multiplied the square root of x minus the square root of a times the square root of x plus the square root of a, what did we get? We got x minus a. So did you know that we could factor x minus a as square root of x minus a, or sorry, square root of x minus square root of a times square root of x plus square root of a? Because if you think about it, x is the same as the square root of x squared, a is the same as the square root of a squared. This is the difference of squares. Something, u squared minus v squared is u plus v times u minus v. And we've already shown if you FOIL this out, you get this. So if I start from the very beginning, here's the same problem that we started with from the very beginning. X minus a, I can go ahead and just write that as a product of, factor it this way, right? And now, again, notice what happens. This factor and this factor are the same. We can cancel those out, and I'm left with this, which is exactly what we had up here. And I can plug in x equal a and get right to it. So this is a little bit quicker than, sort of what we did up here by rationalizing the numerator, if you realize this. So again, you might not see that right away or think about that, but that is a possible way. In both cases, though, remember, I'm using equal signs. I'm keeping the limit each time until I plug in and evaluate the limit, and then it's gone. Okay, hope this helps.